Hello.
Right, so we've just been to speak to Professor Beardmore. He's a mathematical biologist about modelling kill switches.
It turns out it's an awful lot harder to model than you would expect. There are a lot of things going on.
We were talking about how long would the background mutation rate take to make our kill switch stop working. He basically said E.coli will take your plasmid or part of your kill switch in the genome and just spit it out way before any of that goes on because of the energetic cost of maintaining it.
He also said that the scale you're looking at was very important. Everything's on a population level for that questions you can actually get answered with a model. You can't really be so specific because
E.coli's a mess.
As he put it, it's a mess. It's very chaotic, and you can't really map that very well.
And then we went off on a tangent, and so there was a bit of a lull. He basically said all the things we wanted to model were too difficult, and that our idea about a repressor was going to be too messy. And he started talking about position on the chromosome for antibiotic resistance, because his work has been in modelling antibiotic resistance. And he was saying about how even without division, and he said none of this has been proven, but even without division, if you have resistance on a chromosome near the origin of replication, that even in his control, when he just dosed it with a really, really high dose of antibiotics, 5 days later, there was a triplicate of the resistance when they hadn't been dividing. And so that made us think, we're thinking, it's not really iGEM, we can't really build something out of that, but it's really cool.
It did get us thinking, what evolutionary things can we look at with iGEM and the biobricks we have available to us? What big questions can we answer?
Which is something we hadn't thought about at all before. We were always thinking producing something, indicating something, rather than from a research point of view, what can we look at? So we went to talk to Paul after, and he said that we could, using a CRISPR system, if we use someone else's, look at integrating our plasmid in different parts of the chromosome and characterising that and seeing the effects of putting it in a really high metabolic area or a place where not much goes on, and seeing what the difference in expression would be. So that's something that we looked at and thought was really, really cool, because it basically takes something that is really highly regarded, that you need, for mutation and for evolution, you need the cells to be dividing. And from what Professor Beardmore has been saying, that's not necessarily the case, and if it's a simple enough experiment to just give our E. coli a load of antibiotics and put it on different places, I'm really excited by that. If we can fit that into iGEM, we can make that a engineering type problem.
There was we discussed with Professor Beardmore the potential of creating PAF, the penicillin
antifungal protein,
and he was very intrigued by that. In fact, that was the most positive idea that he saw, wasn't it?
We didn't even go into that much detail about that one with him, did we?
No.
He was talking about tunable promoters for that sort of thing, so I think that's something we'll probably take a bit further as well. We now need to go away and find a really specific question that we want to model, so time frame, position of chromosomes, something like that, and then he said to go back and then he'll give us some proper help.
Well, I think that's all for now. Bye.